Channel. Today we shall be looking at this question: convert binary number in a linked list to integer. So the question says, so we want to do it within the allotted time, which is 15 minutes. Given head, which is a reference node to a singly linked list, the value of each node in the linked list is either 0 or 1. The linked list holds a prime binary representation of a number. So return the decimal value of the number in the linked list. So this is an example: 101 at 5. So in page 2, because this will be 0, 1, 2. So that will be 1 times 2 raised to the power 2 plus 0 plus 1 times 2 raised to the power 1. That gives us 5. So that's pretty straightforward. So the constraint, the linked is not empty. Number of nodes not exceed 30. Each node value is either 0 or 1. Okay, so how do we go about that? So what we need is, we need to traverse to get the length of the linked list first. So we need to first of all go from the beginning to the end and get the length. Then we start all over from the beginning and start multiplying the first value by 2 raised to the power the length minus 1, and we keep accumulating that and we return the output. So that should take us big O of n. So we're looking at time complexity of big O of n, and we're looking at space complexity of also big O of what is the space complexity? Our space complexity should be big O of 1. Is that correct? Yes, because we are now keeping the values anywhere. We're not storing the values anywhere. So we're not using any growing space. Okay. All right. So what we want to do is we want to keep a new head. So can we say head dummy? So we want a dummy head to be equal to the head. So here we need to get the length of the linked list, length of the linked list. Okay. So how do we get the length? Yeah, to just get the length, we just need to declare a counter to be equal to 0, and we say y, and there is the head. We with a counter plus equals to 1, then we move the head equals to head dot next. Okay, so at the end of the day, this will give us the length of the list. So now once we have the head of the list, the next is for us to now get the total, which is the binary representation. So we can initialize the total to 0. Then we go through the linked list one more time using the dummy head, head underscore dummy, because we're starting from the beginning again. And what we now do is that we will say our total is equals to whatever value is in that head underscore dummy, the current node. So we need to get the val. So this is the val. Then we multiply that by 2 raised to power the length, which is counter, okay, minus 1. Or if you don't want to do this counter minus 1, you can just come in here and update the counter before coming into this. So we just update the counter because we know we want it to start from so let's say here the length is 3, but this one will be multiplied by 1 times 2 raised to the power 2. So we just decrement that so that it starts from there. So we don't need to subtract from the counter anymore. And so when we do this, we want to decrement the counter because we have used that by 1, and then we want to move our head underscore dummy to the next one. So we want to move the pointer to the next one. So we move that. And at the end, we want to return our total because that's the final. So we want to return total. Okay. I think that's about all that we need to get this done. So we're still within a very good time. We have just used like roughly 6 minutes. So let's do a walkthrough and see how well this does. So we have this, and okay, so head and dummy is the same, so they are all pointing to 1. Our counter is 0. Why head? So there is something in head is 1, so our counter becomes 1 here. Then our head becomes 0, so it moves to that. So y head, counter becomes 2, the head becomes 1. Y head, so counter becomes 3, the head becomes none. So there's no more head, so counter is 0. Here we decrement, so the counter becomes 3 minus 1 here, so it becomes 2. So we come back again to y head. This is 1 because we are starting again from the head. So what we do here is we do this calculation, which tells us that head.dummy.bar, which is 1, multiplied by 2 raised to power 2, 4. And so this the total becomes 4 here. Our counter becomes 1 here, and our head underscore dummy becomes 0 here. So y head on the side, so we have that. Then by the time we do this one, because this value is 0, so this remains 4. So the counter becomes 0 here. Our head underscore dummy becomes 1, and y head, so we come here, so this is 1, and this is 0, so 2 raised to the power 0, 1, so this becomes 1 plus the total, current total is 4, so this becomes 5. So our counter becomes -1, and our head.next becomes none. So here we don't have head anymore, so we return the total. I think that does make some sense. So let's see our base cases like this one. Okay, let's use this base case and see how this works. So this is a single one, so our head is 1, counter is 0, y head, so it goes, so our counter becomes 1, then our head.next become none, so counter is 1, so counter becomes 0 here. Our head dummy is 1, so 1 times 2 raised to the power counter is 0, that is 1, so that is 1 times 1 plus 0, that is 1. So our counter is 0, so this becomes -1, this becomes none. Then we come here, this is none, so our total it's 1. So that's correct. So let's run that and see what we have. Okay, that passes. So let's see all the other ones. Let's see this. And let's see this. Okay. Good, so it passes all of that. So let's submit and see what we have. Good, it passes out. Okay, thank you very much and see you in the next one.